Section 2.5 is all about scatter plots and lines of regression. So some of the Algebra 1 things you learned, plus a little bit new on the Algebra 2. So bivariate data, if you notice here, anything bi is usually 2, right? So variate, having to do with variables. So data with 2 variables. And so basically we usually use a scatter plot or a dot plot to graph these kind of relationships. And so if you notice that the dots that the data that you're plotting kind of has this trend that looks like it's kind of going upward, then you would say that that has a positive correlation. You can draw a line of best fit, kind of an average line or an estimate line called a trend line, to see which one best fits the data that you're seeing, and so you can kind of get a better idea of the kind of correlation. So in this case, if your points are going upward, you call it positive correlation. If it seems that once you graph your points that they have this trend to come downward towards the right, then we say they have negative correlation. And of course, sometimes points are just so all over the place that it looks like they're not related. They're just, scattered all over the place. Then in that particular case, we would say that they have no correlation. So we could always draw, like I said, that prediction line, which is called the line of best fit. It's a trend line, just to see if we see a pattern in the data. A regression line, that can help you determine it's through calculations, but it helps you determine the distance of the points. So how far are these points away from the line of best fit? And so we're hoping that we can keep that at a minimum, right? So that would be a regression line, the line that you can draw that has the smallest distance of these points to the line. So we can do that in the calculator, and you may not have calculators at home, but we will talk about that correlation coefficient either way. So what is that? Well, that is the number. That is the number that you get that measures the data of the model, right? And we're trying to keep that number relatively small because we want to make sure that that's that measurement of how far these little points are from the line. So that's called the correlation coefficient. So if the value that you discover is close to -1, then the points have a negative correlation. If the correlation coefficient is 0, then the data have no relationship whatsoever. So kind of like this situation here. But if the R is close to 1, then the data have a positive correlation. So you'll notice your correlation coefficient is going to be a value that's going to be between -1 and 1. So you wouldn't get an R value of 70, right? Because that's way past what you're expected. So we're going to be looking at that in the examples. So in your packet, you've got the vocabulary and again, the explanation of the things that I just mentioned. But now you'll have actual examples to look at to try to do some work. So if you know times you want to create some kind of equation, right? We usually use a calculator, but you can do it, of course, by hand. So what you would do, of course, is you need to find certain things. So, of course, the rate of change, the slope of this predicted line that you want to come up with. And so you would basically use the same steps that we did in the prior sections of this course. And so to come up with a prediction or something, predict an equation that you think might come out that would be close to what the data that you're seeing. Here you see an example of how to do that. And so, of course, they want you to notice how this, if I were to say this, if this was my trend line or my line of best fit, it's not a very good one. If you notice the data are here and yet the line is kind of dropping off here. This one, you can tell it's a positive correlation, but yet the line looks like it has some kind of a negative slope. So I would not, use that line. This is extremely, the points are coming this way, yet the line is coming through here. So the line of best fit would be something like this here in letter C. So again, some more practice problems for you to look at. And then, so if you go to the study guide and intervention part, you're going to have some more things to calculate. And so it shows you here how to do these type of problems. So first, of course, calculate the slope. And we've done several examples of that. And then, of course, find an equation that'll predict that data or the trend that you're seeing. So you'll see some exercises here for you to try. And if you continue, the same thing. They're asking you now, you may not have a calculator at home. There are some like Desmos.com. You can go and see if you can plot like a scatter plot and so on. So go ahead and try that. But if not, just try to do it by hand. And so the same thing with these practice problems here. It's just a matter of taking these points and plot them. Same thing with these creating these graphs using the information that you're given. Just be careful with the units that you're using here. In this case, it's in feet, and so the temperature is up this way on your y-axis, and the altitude being here. And so just kind of make a note of that, because sometimes it changes from problem to problem depending on the information that they give you.